So let's start with that. So to be clear here, this is our standard point. Again, f of x equals x squared. This is our parent function. Okay, parent function. Now, if this is a parent function, that means that everything is what we expect as a standard. Okay, this is our standard vertex. Again, this is our standard vertex. But because you have a minus h and a plus k, this is telling you to shift left, right, and up, down. That means my standard 0, 0 is always going to follow with the left, right, and up, down. Therefore, my vertex is going to change into h, comma, k. Now, again, as you mentioned, you're very correct in here. We're having a crazy x, so that means if we minus h, we're just taking h. If we plus h, then we're going to have a negative h in here. So based on that, again, normally, if I'm not shifting left, right, not shifting up, down, I'm starting at the 0. Let's take a look at this. We're going to, in here, we're going to analyze every single one of them and then tell me where's the axis symmetry. Now, again, axis symmetry will be overlying on the same exact coordinate for the vertex, but it's just the x coordinate. Okay, so let's take a look. In here, I have this. Do I have an h?
Mm.
I'm going to write this.
Yeah.
Do I have an h?
No.
No, I don't have an h. Therefore, I'm only having a plus 2. Where did plus 2 tell me to go?
Plus 2 goes up 2.
Here we go. So that means I didn't go left, right. I have up 2. So my vertex is at 0, comma 2. So that means where will be my axis of symmetry? Since I didn't go left, right, that means my axis of symmetry did not move at all. So what would the axis of symmetry be?
The axis of symmetry.
Now, axis of symmetry should start with x equal with something. That means I'm going to have a vertical line going down in the coordinate. But in here, since I didn't move left or right, so where should be my axis of symmetry?
The axis of symmetry. 2.
Now again, the 2 is telling me to go up. Now I'm going to visualize this for you. In here, normally I have a smiley face like that. Since I didn't go left, right, I'm just moving up, so I'm having a smiley face looking like that. Now again, I didn't move left, right. That means that my axis of symmetry did not shift at all. Again, the axis of symmetry looking like that. I should have an x equals to?
X equals to 0.
Exactly. So this is how we have the answer in here. I'm going to go erase this. I'm going to leave the axis equal to 0 back there. So in here, this is x equals 0. So based on the same exact formula, what did I do here? What happened to the graph?
The graph goes down.
Down
by 5.
Down by 5. So that means where's your axis of symmetry?
0.
Exactly, since I didn't shift left, right at all. Now in here, what did I do exactly in the 17?
17?
Yes, question number 17, what did I do? Hurry. Look, what did I do? Compare with the x minus h parentheses square plus k. What do I have? What do I have extra?
1.
What is this 1 going to help me to do in the graph?
The 1 is going to help you make the graph go down by 1.
Perfect. More specifically, go down by 1. Very great job describing it. So based on that, what is going to be my axis of symmetry?
Your axis of symmetry is going to be 0.
Perfect. So based on that, look at this. Don't forget we're identifying the vertex. So I have a 0, comma, negative 5, just like what you said, because we go down. Here just now we have 0, comma 2, just like we had. And this one is going to be 0, comma, negative 1, since we go down. Okay, next one. Go ahead. Number 18. What did I do exactly? Describe it.
You go up 0.5.
Perfect. So where's my axis of symmetry and where's my vertex?
Your axis of symmetry is 0.
Wonderful. And then?
And your vertex is 0.5.
Okay, next one, number 19. Exactly what did I do, and where's my axis of symmetry and vertex?
Your axis of symmetry is 0,
Keep going.
and then your vertex is 0, comma, negative 2.25.
Perfect. Next one. Keep going. We're gonna move this up fast because we already know the drill.
Hold on.
Number 20. I know you're writing this down, but let's go. You have this note also after this. So we're gonna move on fast here.
Okay, 20.
Yes, number 20.
So that would make it x equals 0,
Wonderful. Moving on.
0.50.
Wonderful. Move on next. 21.
X equals 0, 0.7.
Wonderful. Next. Number 22.
So now x would equal positive 1.
Wonderful. This is the crazy X. This is actually telling you that I'm going to my right by 1. So don't forget X equals to 1 now.
And then there's no the y, so that one becomes 0.
Wonderful. 1 comma 0. Since I'm not going up down, therefore I have 1 comma 0. Next one, number 23.
X equals negative 2,
Wonderful. Keep going.
and then negative 2, 0.
Wonderful. Since I'm not moving up down, since I'm plussing a 0 at the end, since I didn't do anything at the end.
X equals positive 6,
Wonderful. Move on.
and then it's 6 to 0.
Wonderful. Next.
X is equal to 0.5,
Wonderful. Move on.
0.
Wonderful. Next one.
X equals to 4, and then 4 with 0.
Wonderful. Just like that. Amazing. Next one. Let's take a look at this one. It says each graph is shown is translation of a graph of f of x squared. Again, this is our parent function. This is our standard. Again, the standard looking like this with a smiley face crossing the center, just like that. Okay, this is our standard x squared. Now it says, oh, write each function in the vertex form. Now, vertex form shouldn't be crazy because we have practiced for it for the past almost like 10 questions. So the vertex form will have x minus h parentheses squared plus k. Again, the other one looks like the same. We're just replacing these numbers by finding where's my vertex. And then also double checking for your coefficient. There's like a in the front, if there is. If not, maybe this fine. Okay, let's double check for the first one. Find me the vertex now. Number 27.
The vertex would be like x comma y, right?
Yes, exactly.
Okay, so the vertex is 2 comma 3.
Wonderful. So 2 comma 3. Now let's go ahead and say, oh, x minus 2 or plus 2?
It would be x. Wait, hold on. That one, x2 would be x, so like it would be minus 2.
Wonderful. Again, we're just copying down according to the formula. So don't be confused with any of the sign change. Now we're describing it as a crazy x because we have action of minus 2. That means we go to the right by 2, which is the correct precision in here. I'm going to have a plus 3. So how would I check for the coefficient letter a? How would I check for it?
You check for it by like
finding another point. Let's take a look. In here, I see a 0, comma 7. 0, comma 7. So what can I do with that? I can actually plug it in and see if it's going to be working for the same coefficient, right? So by plugging 0 minus 2, I have -2 square, I have a 4. 4 plus 3 is 7. Therefore, my coefficient is just a 1. Okay? So in here, how would you find a coefficient? We're just plugging in number, other points, again, other points to see if it's going to be working. Okay? So, good?
Yeah.
27? Okay, let's go and try number 28. What's the first step? Just like what we did. What's the first step?
The first step is finding the vertex,
Which is?
which is -3, comma -1.
Wonderful. Now in here, that means I'm going to replace it a x plus 3. Don't forget, since you're moving to the left, crazy axis. Or also you can plug in the -3 in the h. Negative, negative makes a positive. After that, -1. But again, I need to look for another point. I'm going to change the color. Look for another point to test. You can look for this one or this one, either one. So let's see. This one is actually a -5, comma 3. Or you can have a -1, comma 3. Either one will work. Now let's plug it in. -1 plus 3, parentheses square minus 1. Let's see how it's going to work. And then with the -1 plus 3, which is a 2. 2 squared is a 4. 4 minus 1 is a 3. So that means my coefficient is still a 1 again. Okay, since that all the number matches up, so in here, my coefficient is still 1. There's nothing I need to change. So therefore, the vertex form is just here and here. I don't need any of the, this one. I don't need any of the coefficient. Just like that. So far, how do you know that to check for the coefficient? I know they didn't mention it in your example, but we should. So how would you check for the coefficient? Tell me.
You check for the coefficient by like going to like the top one.
Mm-hmm.
And then when you're at the top one, you like
Pick a point and then pick a point and do what?
Plug it in.
And plug it in. Wonderful. Just like that. Okay, let's move on to the next session. Identify the vertex, axisymmetry, and direction of the graph for each function. Compare the width of the graph to the width of the graph of x squared. Now this one, look at this one. If we are looking at question number 29 all the way to 32, they all have a coefficient. Now again, just now we haven't mentioned it, and now is the time to see them. Look at this. We have a 2, we have a nothing, we have 0.75, we have a 3. Now again, be careful with the sign. But when we have a sign, it just means that we open up or open down for the happy face or sad face. So first thing, let's double check. The first question, do I have a happy face or a sad face?
You have a happy.
Perfect. And then question number 30, happy face or sad face?
Happy.
And then for number 31, happy face or sad face?
Sad.
Sad face. And then number 32, happy face or sad face?
Sad.
Perfect. You did a wonderful job, but can you tell me that why does that making a sad face and why does that making a happy face?
Because you're multiplying a negative, so then it become a negative and then it would be going down.
Perfect. So negative means that I'm having a concave down. Concave down in here means that I'm going to have a frowning face. Okay. So let's come back and take a look in here. We are looking at the vertex, axis symmetry, and direction of the graph change. Let me change the color here. It'll be easier to see. Okay, so first thing, I am not having any of the axis. I'm going to go ahead and create my axis. First thing, I am having a happy face. I'm expecting most of the stuff to be above the graph, so I am maybe expecting a graph looking like this. And then now, and again here, the 2 is going to tell me that everything's going to go taller. +1 is telling me to go left or right. Tell me. Does that go left or right?
You should go left.
And what about the +4? What does it tell me to do?
The 4 go up 4 times.
Perfect. So I'm having something that's a happy face, going to the left by 1, and going up by 4, and then possibly multiply by 2, because that is what a coefficient do. That means I'm going to have something that is looking like this, because I'm expecting something to happen on the upper left side. So in here, I'm going to draw my axis grid a little bit further away. So X, Y, that's cool. Now again, I got double up. Maybe I should start with like 0, 2, 4, 6, 8. So 4, 6, 8. Maybe I'm drawing a grid smaller. -2, -4, -6, and -8. That might be better. Let me use an eraser to make it better. Okay, so tell me, if I plug in that, I already know that I go left by 1 and go up by 4, so that means I should have something right here to be my vertex. Again, left 1, up 4. And then let's go ahead and try. If I plug in 0, what would I have?
If you plug in 0, you would have mm,
0 plus 1 is a 1. 1 squared is still a 1. 1 times 2 is a 2. 2 plus 4 will become a
2 plus 4 will become a 6.
If I plug in a 0, I would have a 6. Now again, based on that, hold on, I need 2 point, I think is going to be good enough to do a sketch. Because I know that axis of symmetry will be definitely lying on the same place with the vertex. And I know that if this is one distance away, that means this is going to be one distance away. So I'm going to have a graph, something looking like that. It's looking really, really sharp. Okay, so let's come back to the question again. I need to have a sketch, and then vertex, oh, I already know, because I'm having a left 1 up 4, so I'm going to have a negative, I'm going to have a -1, positive 4. That is going to be my vertex. And then x of symmetry, oh, since of that is already landed in -1, so I'm going to have x equals -1. And then direction of the graph for each function. Well, I know my left end is going up, my right end is going up, so both end is going to be positive infinity. Or you can say happy face. Okay, let's take a look at number 30. How would you do it? Let's analyze
Number
it.
30. First you make the graph, and then the -3 would be going right, and then like the -3 after you have that.
What's the -3 do at the very end? Up or down, left or right, what does it do?
-3 goes left.
But what about the second -3?
Goes down.
So I'm going to go left and go down. So I should have a graph something like that. Because I'm expecting it to be left and down. And then also right and down. So I'm having something right and down. That means I'm going to expect a space on the lower right side. So I'm going to go ahead and erase stuff a little bit. My eraser's not working. Okay. The writing board's giving up on me. Give me 1 second. Okay. Okay. Wonderful. The writing board's giving up on me. Give me a second. Okay, I'm expecting something that is right and down. This is a horrible stroke. Let me try it again. Something on my right and something that's down, and also something that's smiley face. Now I go right by 3, go down by 3. I should have something right here. Since not all of the smiley face were having a regular coefficient of 1, that means I'm having something like this. And then after that, 1, 2, 3, 4, something like that. We should remember this very easily. Just like that. And then where's your vertex?
Your vertex is in the middle of +3.
3. Okay, but hold on. Vertex is the point itself. You're talking about the
Three
axisymmetry.
to the 3 comma -3.
Wonderful, you're correct. Now again, in here, the vertex is the point itself, which is where the pointy, where the point is actually turning on the graph. And also that, where we're talking about the axisymmetry, I'm going to talk about the whole entire line that goes up, down, that pass through the vertex. Okay, and then we're going to have a direction. The direction is both ended to be positive. Let's take a look at the next one. In here, we're going to have a negative 0.75, negative 5, and then plus 6. Well, what does everything do? Tell me what exactly is happening. Go ahead.
So it's you take the x and then you move it forward to +5.
Okay, so that means I'm moving to the right.
And then +6, so it's gonna be the vertex is -5 plus 6.
So, no, vertex is not negative 5 plus 6. You just told me that you go to the right.
Oh wait, 5 comma 6.
There we go, 5 comma 6. That means my x is equal to positive 5. So based on that, I'm having a point of 5 comma 6. I should have been something that's on the right side, upper right side. Three-handed grid is not pretty. Give me 1 second. Try to do better. Great. And then here, wonderful. 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Oh, very, very close. Okay, now I have 5 comma 6. This is going to be a vertex. And then, but the thing is, I have a frowning face and also a 0.75 as a coefficient. So what am I going to do? I'm going to go ahead and plug in the numbers right next to it. I can try number 6. I can also try number 4. Give it a try. If you plug in number 4, then you have negative 0.75 plus a 6. So what you have?
You have
Negative 0.75 plus 6. Or in other words, you can have 6 minus 0.75 if you plug in a negative 4 as a calculation. Sorry, positive 4 as a calculation.
Yeah.
You have a point about 5.25. And then if you plug in a 6 minus 5 is still a 1. 1 squared is still a 1. 1 times negative 0.75 is negative 0.75. Plus a 6 is going to be a 5.25, which is here again. Again, why does this happen? Because we know that axis of symmetry is going to create an imagery from the left side to the right side. So again, approximately, I'm going to have a picture looking like that. Okay, now the 0.75 is actually making the graph more flat, so I should actually draw it better. I can have a flatter graph looking like that. Now this is a sketch, it's not accurate, but you know that there's a frowning face and a happy face. Okay, let's take a look at the other one. In here, I'm going to have a +2 and a -5. Tell me exactly what do they do.
So like the +2 would become a negative.
So that means what? Don't tell me negative, tell me a direction. What did that do?
Left.
Yes, it's going to go left. And then that means I'm going to have a -2. You're correct. So I'm going to have a -2 comma what?
-2 comma -5.
Wonderful. -2 comma -5. So that means I'm expecting something on the lower left side. So I should have a graph something like that. Okay, and then lower left side. So I'm going to move on to left to the 2, and then go down 5. 1, 2, 3, 4, 5. So I'm going to have a spot right here. Again, because this is a sad face, so I should have something looking like that. But where will the exact point be? Well, let's go ahead and take a look. Again, we're always taking plug in points for one on the left and one on the right. So that means we can plug in -3 and also we can plug in -1. Now again, no matter how you take the distance, that this one's always going to be 1 in here. That means I'm going to have an answer for -3, -5. That means I will have an answer for 8, which is somewhere right here. Okay, it's going to be super sharp like that. Okay, so let's take a look between number 31 and 32. If you see 0.75, I should have a flatter graph. That means it's going to be less like tall. It's going to be flat. The more that I climb, and actually the slower I actually increase. And then I'm going to have a -3 as a coefficient. That means I'm going to times a huge number. So based on that, I'm going to have a super skinny, sharp graph. Okay?
Okay.
Okay. Let's take a look at number 30.